Welcome back to part 2 of this building the fireball tool style vise. If you have not seen the first video, you can find a link down in the description. Where we left off, the vise was pretty much completed. There's just a few things to finish off. And to be honest, that video went for quite a while and I wouldn't be able to get all of these last items into that last video. Otherwise it would have been far too long. So there's three main things we need to do here. The first thing is I need to make some jaw blocks that go in here. And these jaw blocks will be just over 5 inches long, so about 130 millimeters long. And they will be welded in here with some... we'll put some threads in the back and then our jaws will be able to bolt to these jaw blocks. The second thing I need to do is make a spanner for the nut in the front here. So across the flats, this is about 42 millimeters. So it's kind of a large nut and I need to make a spanner that fits on that. And if you look at the video Jason did on building his fireball tool vise, the spanner he made had 2 hexagons in it. So one is on the end of the bar and that gives you a lot of leverage, and the other one's in the middle of the bar and you can put that on there and that gives you a lot of speed. And the last thing I want to do is make a swivel base for this vise, and I've put a link down in the description to someone else who made one of these tube vises based on the videos he watched from Jason, and I really have to admire how he's done it. I don't think he actually used a lathe or a mill in that build, so I really got to commend him. He built the whole thing without a lathe and a mill, just with basic tools, and he actually built the swivel base. And without a lathe and cutting the chamfers, so that the swivel base can mate with the other parts and work properly, he made jigs up and used an angle grinder to make those angles. So it's a great video to go and watch and see how he's done that. That's probably the hardest bit for me, is to make that swivel base. I do have a lathe, but I think I'm at the limits of the plates that I'll be making, and I will use some of that person's design on making the swivel base because I'm not going to get everything in the lathe. So I'm going to start on the jaw blocks and get those made and get those welded in. Then I can take out these spacer parts. I've got one of the blocks milled up and it fits in here really good, so there's no issues with that. But the problem is, I think this is actually cast iron. It came from parts of a dental chair that I'd picked up along the way. So I think I'm going to actually have to find something else, because I won't be able to weld that on there being cast iron. So I'm going to have to go to plan B on that one, I think. I got the jaw blocks for the vise pretty much finished. I've drilled some just over 6.5mm holes here, and these will be threaded out to M8, and then the actual jaws will be able to bolt to that. And what I was going to use for the actual jaws is a piece of aluminium. Now I have this piece here which is about 10mm thick, but I wanted something a little bit thicker than that. So I think I'll make the actual jaws a little bit later, and the plan is I will melt down some of those aluminium ingots that I made in one of my videos there, and I'll cast them into a bit of a mold to make some, you know, aluminium bar stock. It's kind of like this shape, and then I'll be able to machine it up and then bolt it to the front of the jaw here. The next step is to weld these on, and I did find a small problem which I just need to correct first. So this fixed jaw fits into the slot here nicely, and you know, if I push it down and back there's no movement there. However, the front one of these jaw plates must be slightly off alignment because there's a little bit of wobble there. So I'm going to actually put this in the mill, and I'm going to re-mill, just take a little bit out of here until they are all the same height. And to stop the movable jaw, you know, moving around in the mill, I was just going to get our piece of cast iron that I machined up the other day and place it down below the cutouts, and then just tighten the vise up so that it puts a bit of preload on there, and that'll sort of put the movable jaw in the position where it would be naturally when being squashed up as well. So now when I mill out these recesses for the jaw blocks, they will all be exactly the same height, and will be all parallel, and everything should work out perfect. I got the jaw blocks welded on. That came up really good, and they're nice and square, so you know, they're ready to have the aluminium or soft jaws bolted on here. But I need to make up those aluminium jaws. I'm going to do that a little bit later. So the next job is to make the handle for the nut here, and I've got this piece of 60mm by 10mm thick piece of steel here. And the way Jason done it, he had a hex down one end here. I don't know if you guys will be able to see this. So there's a hex down there, and then he had a hex kind of in the middle-ish somewhere. And then he had the handle sort of scooping down like this type of thing at the end here. And he had a little handle that sticks out like a speed handle that, you know, has a sort of a swivel thing on it and you can spin it round. So the hex way down the end here, that's where you would put it on the nut here for, you know, all that leverage if you needed to tighten something up. If you need to wind the vise out, because it has, you know, an M20, I think it's by 2mm or by 2.5mm thread pitch, that can take quite a while to wind it right out. So that's when you would use the hex up this end, and you just use the speed handle to spin it around really quick, and that gets that vise open pretty quickly. So I'll go off and mark this out, and it's going to be a little bit of a new sort of piece of work for me, cutting out a hexagon on the mill, but it's always good to learn something new. Okay, so to work out these hexagons that I need to cut out of the steel, I've just got a bit of paper and some numbers on here to do some calculations. So basically it's a mock of this piece of steel here. It's a little bit shorter here, but we're just focused down this end where the hexagons are going to be. So this, across the flats here, this size here is 42.7mm, and it's a bit of an odd size, and it's because it's based on the outside diameter of the round stock that I had at the time. So after I'd cleaned it up, then I cut the flats into it to make the hex based on that outside diameter. So I don't know what that outside diameter was, but whatever it was, it worked out to be 42.7mm across the flats here for those flats. To work out the hexagon that we need to cut out, we need to work out what that outside diameter is again, and I can probably measure across the longer points here, but I mean these were sort of, you know, the edges were ground down a bit on the grinder, so that's not going to give us an accurate number. So what we can do with a hex, there's actually a constant. They have one for hex and they have one for square stock as well. So if you have the, you know, across the flats measurement, you multiply that by this constant number here, and that'll give you the outside diameter, or the diameter of the round stock that you need to start with to cut a hex of this size. And same for the the square stock here. So in that case, multiplying our 42.7 by this hex constant gives us a diameter of our round stock of 49.3mm. And that sounds about right, because this piece used to be a 50mm piece, and by the time I cleaned it up, it, you know, took off about 0.7mm. So the radius on that would be 24.65. So if I measure, and you have to excuse my compass here, I really need to go buy just a decent one. This is like out of the, you know, the kids' school kit or something. But anyway, if we measure, it's a little bit hard to get it exact, but I mean this is kind of going to give us a good idea. And on the bit of paper here, I've got a mark here, and I've got a mark here. So basically what I want is the point of the hexagon to be in there, because I want the flat sides parallel with the sides here. And the reason being is because that's going to give me more metal between the flat side and the edge of the metal, as opposed to having the point. The point would stick out further, and that would give me less metal there. So what we can do is we can start on this mark and we can scribe a line here, and that's going to be the center of our circle. I'm hoping this thing doesn't move on me. Okay, so we've drawn our circle there. Now the radius from here to here is the same size as across the flats here. So what we can do in that case is we can start at that point and we can scribe a line there and a line there, and then we can start on that point, a line there, start on that point, a line there, and then that will give us our sides. And if I just quickly draw these up with my very blunt pencil, then we're going to end up with something like that, which is pretty much what I need. I've given it 10 millimeters at the end. This piece of steel at the end here will be sort of rounded off, I guess, like that, just to give it some, you know, make it look a little bit better. And then we will draw our hexagon up here, so we're still using the same size. And that's our second one there. So theoretically, across these flats here, this should be 42 point, and it looks, I mean, this is kind of very rough and ready, but it does look like it's, you know, 42 and a half-ish. It's pretty close to what we want. So basically what I'm going to do to cut these out, you can see I've got the same 10 millimeter gap here, so basically the hexagon's going to be, so what I'm going to do is I'm going to find the center of the hexagon, and I'm going to put the center drill here, just a little mark. And what that's going to allow me to do, I have a rotary table. I was very fortunate. I got it with the mill. The guy just threw it in with the mill. So it was a real bonus to get that. I don't use it very much, but on a job like this, it's absolutely fantastic, and you know, it's going to make this all work out. So I'm going to put a center drill in here. That's going to give me the center of the hole, and that center of the hole is going to be right in the middle of the rotary table. And then we will cut our, or drill our holes in the points here. And then once we have that done, then I can use an end mill and go across the flats. And then once we've done those two flats, I'll be able to rotate the table and then do these two flats and then rotate the table the other way for the last two flats here. So when we work out what our radius distance is, that's not actually what we'll use in the mill, because if I do that, and this is only exaggerating, if I did that and my drill bit was drilled here, right in the center of that line, you can see that I'm going to actually drill outside of the flat area, and that's not what I want. So whatever size drill bit I use, and it's probably going to be something like a 3 millimeter or 1/8 drill bit, I need to have the edge of the drill bit on the right on the edge of this point, so that when I cut along these lines here, I just break into where that drill bit has gone through the steel at both points here. And then that will give us kind of nice, you know, sharp corners, because our drill bit will be drilled in like that. So we need to come in half the thickness of the drill bit, which is going to be 1.5 millimeters if I use a 3 millimeter drill bit. So that's what the radius distance will be. So the holes will be actually a little bit in, but we will make up for that by using the end mill to come right to the edge of those holes. So that's the plan, and as I said before, haven't done this before, so it's a learning experience, and we'll see how all that works out. Okay, so here's the setup. I've centered the rotating table, so that's right in the, that'll rotate around the center of the spindle. I've got the rotating table set to 0 degrees. All the rotations will be 60 degrees apart. And you could probably do this without a rotating table if you were able to move your work around 60 degrees with some sort of protractor or something like that. I've drawn a couple of lines here on the rotating table, and that's for the piece of wood that I'm going to be using as a sacrificial back plate type thing, so I can drill and mill into the steel and right through into the piece of wood. So that's going to just line up with those lines, which is straight across, and that'll give us the edges of our hexagon parallel with the edges of our piece of steel. The piece of steel goes on top. I've countersunk or center drilled these, and that's so that I can line this up right in the center of the rotation with this center drill here, and then we can just rotate on that axis. So I'll get this all clamped up and then we'll start cutting. The next step in this Vise build is to build the aluminium soft jaws. So to do that, I actually had to cast some aluminium because I didn't have any aluminium that was suitable. And I don't know if you've seen my video on the results of casting aluminium round stock, but for all these castings here, I heated up the mold every time, and all of these came out very, very easily. You know, still needed a tap with a hammer, but really easy. Nothing got stuck in there. So I think the trick to, you know, casting the square and round stock and your molds is to heat them up, get them nice and hot just before you pour. Anyway, I had to make this square stock here, and this is about 150 millimeters or 6 inches, and it's about 1.75 inches. So the plan is to cut it down the center, and then that'll give me you know, by the time I've machined it up, should give me about 20 millimeters of jaw thickness, or maybe a fraction less. I made it extra long. I mean, the Vise jaws open up to around about 5 inches, but I just wanted to make it extra long because you get a bit of shrinkage in the top here. So, you know, there could be pits around the top or pits around the bottom, like that sort of stuff. So, you know, it gives me enough material to mill or cut away to get into the good stuff. So I don't know what this is going to be like in the middle, but we'll certainly find out, and we'll get these soft jaws made. So I cut down those square blocks of aluminium that I casted today, and I see there is a bit of an issue in them. Now this is kind of a bit weird. The bottom, this is the bottom down this end. It seems to be fine until you get up to 2/3, or just over halfway up, I guess. Then we get this kind of you know, as if there was air or something in there. And it's on all of them. It starts a little bit lower down on this one and then sort of stops as you get to the top. So I really don't know what this is, but it sort of hinders the jaws a little bit. This is the least deep one, so what I might do is I'll put it on the mill and I'll see what I can clean up, and if we're still, you know, within maybe 15mm thickness of a jaw, then we'll use it. If not, I'm going to have to work on some other plan, I think. So as you see there, the soft jaws are complete and in place, and that is working really good. The speed handle is fantastic. You know, you can open this thing up pretty quick. That would probably be as fast as a normal vise, I think. And then, you know, when you need to get in there with a bit of power, then you can put it on the other hex and just lay into it there. That just feels so good and smooth, and man, that is really clamped tight in there. Now I did say that in this video we were going to do a swivel base as well, but I think this video is probably till now going to be around 30 or over 30 minutes long. And to be honest, the swivel base is a bit more complex, so I think that's going to be a video in of itself. So I'll make another video on that one. And that swivel base is the last thing to do for this vise. Then I'll be able to tidy it up and get it painted and mount it to the bench here, so I can actually use it instead of the teeny tiny vise that I have there on the bench. So once again, thanks for watching.